This is the last part of the unit. We're going to learn about the electrons in the atom, focus really on what's happening with those electrons. So looking at today's model, which is called the electron cloud model, which is also known as the quantum model. So first we need to start with Heisenberg's uncertainty principle. He pretty much just states it's impossible to know both the velocity and the position of an electron at the same time. Pretty much they're so small and moving so fast that it's impossible to isolate one and know both of those things at the same time. Schrodinger, he's the main person behind the electron cloud model. He defines the probability of finding an electron, and he calls it the orbital. Now, do not confuse this with Bohr's model, which says orbits. Orbits means to go around in circles. An orbital is an electron cloud. It's just a shape that the electrons exist in. So you've got to know the difference between those two words. So pretty much the electron cloud or the orbital is where there's a chance, a 90% chance of finding an electron in that space. Now, of course, sometimes the electrons wander out, but that's why it's called a probability of finding. Okay, so what we're going to focus on here is the quantum numbers. You've got to be able to tell me what the following things say about an electron. So I'm going to use an analogy here. If you go to a professional basketball game, you have to have a ticket. On that ticket, you have several things telling you where to go. You first are going to have a section that you have to go to. Once you find that section, you then find the row that you're in, and then you find your seat number. The electron is the same exact way. There's not one just place you're going to go. You have to follow the ticket. The quantum number is the address for each electron. So each electron has its very own spot. So the first quantum number is the principal quantum number. This is represented by the letter N. It tells you the energy level that the electron is on. With telling you the energy level that it's on, it tells you the size of the orbital. So for instance, energy level 1 versus energy level 3, 3 is bigger. So the higher the energy level, the bigger the orbital. So this tells you the section that you're going to go in, because this is the broadest part of our quantum numbers. As we go through the quantum numbers, you're going to get more and more specific, just like the ticket. So the next thing is the angular momentum quantum number. So you know your energy level, so then you're walking up to your section, you have to find your row. Exact same thing. This is the energy sub-level, so the row in the level that you're in. It tells you the shape of the orbital. So each row is a different shape. So you have 4 different sublevels, S, P, D, and F. Those are the only 4 sublevels that we have. So they all have different shapes. So S stands for sphere, P is a peanut, D is a double peanut, F is flower. So you will need to know the shapes of these different things. The next one is the magnetic quantum number. This tells you the orientation of the orbital. Now, orientation means position. So each of the sublevels has different positions that they can lay in. So you have to figure out which one that it's in based on the magnetic quantum number. So it tells you the specific orbital in the sublevel. So just like your ticket will tell you your specific seat number in the row. And see, this is D. D has 5 different seats that it can sit in. Pretty much it goes based on the axis that it's on, except for that very last one. This is P. It's easier to understand just because all it does is go from X, Y to Z. It just changes axis. When you combine all of the orbitals together, you will always get a spherical shape. Then you have the spin quantum number. And all it's doing, there's not really too much of an analogy here, except for if you were to be spinning in your seat at a basketball game for whatever. So the thing I use for the analogy is the team that you're pulling for. So obviously there's always just 2 teams playing. So either you're going to be pulling for the home team or the visitor team. So with the electron, it's it's based on spin. So either it's going to spin clockwise or it's going to spin counterclockwise. And it's a weird basketball game because you can have 2 electrons per seat, but they have to be spinning in opposite directions. Okay, this is a very, 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 very extremely important slide. You've got to understand what N tells you and things that you can calculate based on N. So the first thing, N stands for energy level. So if I say N equals 2, then you are on energy level 2. But it also tells you the number of sublevels per energy level. So if I say energy level 2, then that means there are 2 sublevels. If you do N squared, this is the number of orbitals per the level. So energy level 2, 2 squared is 4. So there's 4 orbitals per energy level. 2n squared then tells us the number of electrons per level. Because remember, each orbital can hold 2 electrons. So if n squared tells you the number of orbitals, all you have to do is multiply that by 2. This slide, or this chart, you got to know it. Start, highlight, do whatever you got to do to know it. Your 4 different sublevels that you have here. This is the number of orbitals that they have. This is the number of electrons. So pretty much it's the odd numbers. So if you can remember S, P, D, and F in that order, it's simply 1, 3, 5, and 7. And then to get the electrons, you just multiply it by 2. Okay. This is a huge slide. It has a lot of information on it, but this is one of those things that's going to come easier the more examples that we do. So just sit tight for a second, let me go through them, and then the next slide I'm going to show you exactly what to do with it. So, first off, we're going to fill orbitals. The basic setup is you're going to use an arrow to indicate the direction of the spin. So you're going to put the arrow either up or down. The 3 rules that you've got to know are these. Pauli exclusion principle, which we've already talked about. Each orbital can only hold 2 electrons if they're in opposite spin. So this is just 2. And I had a student that remembered this one because Pauli wants a cracker. She changed it to Pauli wants 2 crackers. Okay, then you have Aufbau principle. The electrons fill the orbital starting with the lowest energy level and working their way up the energy ladder. So just like climbing a ladder in general, it's not like you're going to jump up to the 5th thing to climb up the ladder. You're always going to start at the bottom and work your way up. The electrons are the same way. They start at the lowest, work their way up. Hund's rule, which I call this the empty seat rule. Sublevel orbitals of the same energy must be filled with a single electron before the electrons can begin to pair up. So analogy for this one. The electrons don't like each other. Okay? They cannot stand each other because they're all negative. So, if they were to get on a bus and there's some empty seats with no electrons on it, where are those electrons going to go? They're going to sit in the empty seat. Now, if all the seats have somebody in them, an electron, and you are not allowed to stand in the aisle or whatever else, that electron then has to do what? Sit with another electron. That is what this rule is saying. They're only going to sit with each other if they're forced to. Other than that, they're going to sit by themselves. Okay, this diagram that's in your notes, this is called orbital diagram. We're going to put a bunch of arrows into these boxes. So, starting with hydrogen. First, you need to know how many arrows you're going to put. The number of arrows is indicated by the atomic number. So in the case of everything that we're looking at, it's going to be based on neutral atoms. So hydrogen has 1 proton, so therefore it only has 1 electron in a neutral atom. So when we're done, we will only have 1 arrow. The number of arrows matches the atomic number. So we're always going to start with 1s and work our way across. So for hydrogen, you're simply going to go up, and that's it. Okay, we're going to get a little bit harder. Lithium has an atomic number of 3. So this means we're going to have 3 arrows. So energy level 1 only has 1s. We're going to go up, and before we can go to energy level 2, we need to go down. That's 2 arrows. We need 1 more. So the 3rd arrow then goes to the next energy level. Up. And and you're done. Okay, we're going to get a little bit harder. Carbon has 6. So we're going to have 6 arrows. So we're going to go up, down. Energy level 1, good. Now we're going to go to energy level 2. So energy level 2 consists of 2s and 2p. So all of this has to be filled before we can go to 3s. So 2s, up, down. We now have 4 arrows, 2 left. Then we come to 2p. 2p is a little bit different than s because s only has 1 seat. The electrons are forced to sit with each other. 2p has 3 seats. So remember, Hund's rule says we're going to go up and we're going to go up again. The electrons are not going to sit with each other unless forced to. So for example, K is our next one. K has, and I can't remember this one off the top of my head, 19 electrons. So we're going to have 19 arrows. Okay, so follow the pattern here. Make sure you're paying attention. If you're not getting it the first time, re-watch this part of the video and bring questions to class. So we're going to go up, down, 2, up, down, 4, then we get to 2p. Make sure you're watching this. Okay, that's 4, 5, 6, 7. Now you see how I had to fill all that up. Now before I can go on to 3s, I do need to fill up 2p. So we've got 7 right now, 8, 9, 10. So then we go back and fill those electrons. So that gives us 10. We need 9 more. So where do we go next? 3s. Up, down. Okay. So that gives us 12, 13, 14, 15, 16, 17, 18, 19. Okay, what I want you to do now at this point is pause the video and try to do the rest on your own. You now need to check your arrows and make sure that they match what's on the board. If you have any questions or concerns, please make sure you bring them to class and ask about them so you're able to do these on your own. You now need to color in your periodic table that's on your notes, just like this one. You do not have to use the exact same colors, just please make sure that you have the blocks colored in the same sections. Also need to label what I have on the board. When you are done with this, you are done with the notes.